Hi students, welcome to Max Point of View. Today we are going to learn conservation of energy, which is part C of work energy power chapter. So first we will learn the concept, then we will solve all the questions which is there in the textbook, and then we will solve all the numericals which is there in the textbook one by one, and all those videos will be available in the description box. Now we'll go for the topic. See, this is a very simple topic. Based on this one, in 2020-24 paper, 3-mark question was asked, and it was very simple and very tricky. If you know the concept, it is very simple. If you don't know, you will guess the answer. So better to understand the topic instead of guessing. Okay, now first we will learn the definition of conservation of energy. What do you mean by the principle of conservation of energy? The energy neither be created nor be destroyed. That is the principle of conservation of energy. So this tells I cannot create any energy. I can convert one form of energy to another form. Now we will learn how conservation of energy is related to mechanical energy. Here M is nothing but mechanical energy, K is nothing but kinetic energy, and U is nothing but the potential energy. Listen. What do you mean by mechanical energy? It is the sum of both potential energy and kinetic energy, correct? See, mechanical energy is nothing but the sum of kinetic energy and potential energy, that is constant. That will be always constant only when there is no friction. Only when there is no friction. This is important. Only when there is no friction. See, mechanical energy is constant, okay, only when there is no friction. This is very much important. When there is no friction, the mechanical energy is nothing but the sum of potential and kinetic energy will always be constant only when there is no friction. That is possible in vacuum, when there is no matter. Okay, keep this in mind. This is very much important. Next, how we can understand this statement using an example. Few examples. Okay, listen. Assume there is a ball. Okay, see, in the textbook so much of derivations and lengthy derivations are there. All those things are not important. All those things are not important. What is important, that is what we are going to learn here. Till here we understood, correct? Now we are going to learn how mechanical energy is always constant. That is what we are going to learn only when there is no friction. Okay, listen. Assume there is a ball at point A. Okay, and what is the distance between at point A to the ground level? That is h. You got my point? See, assume a ball at A, and for the height, the distance between point A and the ground is h. Now listen, at this point, now do you think the ball is moving? The ball is not moving. At A it is not moving. So if it is not moving, kinetic energy will be 0. Correct? Kinetic energy will be 0. What about potential energy? Potential energy, we have height. Correct? See, what do you mean by potential energy? Potential energy is equal to mass into gravity into height. The ball has mass, we have height, and this place has gravity. So we have potential energy, that is U is equal to mgh. Correct? YH, that is the height from this point A to ground. Okay, now at point B, this is very much important. At point B, listen, at point B the ball is moving. Correct? At point B the ball is moving. So whenever you convert potential energy into kinetic energy or kinetic energy into potential energy, we can assume the formula for both is same. I'll give you an example. What is the formula for potential energy? mgh. We can take mgh as kinetic energy also. For kinetic energy, whenever you're converting potential energy into kinetic energy, we can use the same formula to find kinetic energy. So at this point we know we have some kinetic energy, correct? Because the ball is moving. At this point the ball was not moving, that is why kinetic energy is 0. Now the ball is moving, so we have some kinetic energy. As I told you, we can use the same formula because we are converting potential energy into kinetic energy. So kinetic energy will be mg, mass of the ball, gravity of that place, and h, height, distance. See, at this point, okay, at this point, what is the height value? That is nothing but x. Then potential energy will be mass of the ball, gravity of the place. Now we have to talk about the remaining height, correct? See, at this point we took this as the height. Now the ball is here, we have to take the remaining height, correct? So how we can get this value? The total value, the h minus x, we will get the remaining height, correct? So this will be h minus x. Now, as I told you, mechanical energy is the sum of kinetic energy and potential energy. We will find here, we should get both the answer as same. Okay, listen. Mechanical energy is sum of kinetic energy and potential energy. In this case, kinetic energy was 0, potential energy was mgh. So finally, that is nothing but mgh. Okay, now we'll talk about this one. Here, mechanical energy is equal to k plus u. K is nothing but mg x. Here mg h minus x. H minus x, correct? So in both the cases, we can take mg as common. Okay, in both the case, mg as common. X plus h minus x. X and x will get cancelled. What is the remaining answer? mgh. That's it. So we'll talk about at C. See, when this ball reaches the ground, before reaching the ground, just before reaching the ground, okay, what will be the height? 0, correct? If height is 0, what about potential energy? Potential energy is 0. If potential energy is 0, what about the kinetic energy? Kinetic energy will be maximum. So at C, k will be mgh and u will be 0. What is the sum of kinetic energy and potential energy at C? It is again mgh. That's it. So this is the concept. See, here we need to understand few things. In here we are assuming this is a frictionless area, frictionless surface. Okay, there is no friction because whenever something is falling down, kinetic energy will be there. And there will be a friction between this ball and the air, correct? So because of that friction, some part of the kinetic energy will be converted into heat energy, but we are assuming this is a frictionless medium, so no part of the energy will be converted into heat energy. So we have complete mechanical energy as constant only when there is no friction. Okay, this is very much important. Now listen, and one more thing. See, here you need to understand that whenever the ball is coming down to earth, potential energy will keep on decreasing. Whenever the ball is coming down to earth, potential energy will keep on decreasing. Why? Because the height, okay, the distance between the ball and the ground will keep on decreasing. If height decreases, potential energy will also decreases because both are directly proportional. Okay, now if the potential energy keeps on decreasing, as you know, if some object is falling down, the speed of the ball, okay, the speed of the object will keep on increasing as it moves because of the gravity, correct? If the velocity is increasing or the speed is increasing, what about kinetic energy? Kinetic energy will keep on increasing. So how much potential energy is decreased, that much kinetic energy will increase. Keep that in mind. Very important statement. How much potential energy is decreasing, that much kinetic energy will increase. So sum of kinetic energy and potential energy will be equal to constant always, only when the medium is frictionless. If there is any friction, mechanical energy is not constant. That's it. Okay, now we'll talk about this example. Okay, here I am not leaving the ball directly like this. Now I am throwing the ball. Now what happens? See, when you throw a ball, assume this is the path it is going to follow. Okay, here we have some height, correct? We have some height, so we have some potential energy. Okay, what about kinetic energy? At this point, okay, at this point, if the ball is not moving, kinetic energy will be 0. It has some potential energy. Now when you throw it, the ball is going to rise up, correct? Ball is going to rise up. As the height increases, potential energy will keep on increasing, So here the potential energy will keep on increasing at this point. Okay, at the topmost point it has maximum potential energy, and at this point there will be no movement. okay, there will be no movement. That is for only fraction of second. At that point there will be no movement. At that fraction of second it has maximum potential energy, and as the ball is not moving, there will be no kinetic energy. At this point there will be no kinetic energy. So here kinetic energy, whatever the kinetic energy it has while moving up, kinetic energy will be keep on converting into potential energy. At this point there will be no kinetic energy, only potential energy. So once this starts falling down, the whatever the maximum potential energy we have, that will keep on converting into kinetic energy. Why? Because there is no height is getting decreased, so potential energy has to decrease. If the potential energy is decreasing, kinetic energy will be increasing. Before reaching the ground, the height, okay, the distance between the ball and the ground is 0. At that point, okay, potential energy will be 0 and kinetic energy will be maximum. Very important formula. This may be useful when it comes to equation. Listen, initial velocity required. See, when you want to throw the ball, we require some velocity, initial velocity, right? For that we are going to find the equation, and it is very simple. We know that mechanical energy is nothing but the sum of kinetic energy and potential energy. Assume both are equal. Kinetic energy is equal to potential energy. What is the formula for kinetic energy? Half mu square. So instead of taking v square, we have to take u square. Why? Because we are talking about initial velocity. Initial velocity symbol is u square, and that is kinetic energy will be equal to potential energy. What is the formula for potential energy? mgh. In both the cases we have mass, so we'll cancel mass. Now we have u square, we'll send this to that side, that is nothing but 2gh, correct? Now we will require only u is equal to, when you send this square to that side, that becomes square root, so 2gh. So initial velocity is equal to square root of 2gh. This may be useful for your exams also, for solving numericals also. So this is how we find the equations required. Okay, required equations. Now I think we have covered everything, and there is one more simple example is there. If we understand that, then everything from this concept we have covered. Now we'll talk about one more application of conservation of energy, that is nothing but a simple pendulum. And this is a very simple concept. If you understand that dropping a ball when the kinetic energy is maximum, when the potential energy is maximum, then this is a piece of cake for you. Okay, here the only difference will be the height. See, when you are dropping a ball, okay, when you are dropping a ball at this point, what will be the height from the distance from this point to the ground, correct? So why we have taken this as a height? Because this is how the ball is moving, the object is going to move. But when it comes to pendulum, okay, you should not take this as height. See, very important thing, you should not take this as height. The length of a string is not the height. Okay, you have to take this movement, okay, as height. See, this complete thing is height. So at this point there is no height, because at this point, see, this is the middle point. At midpoint there will be no distance. From this point we have to calculate the height. At this point, from this point we are going to calculate the height. But at this point, what is the height? H will be 0. So whenever it start moving, okay, height will keep on increasing. Once it reaches the same point, height will be 0. Again it is going this way, then again height will keep on increasing. This is how we are going to calculate height when it comes to pendulum. But when you are dropping any object, or when you are throwing any object, so in which path it is moving, that path we have to take the height. If it is moving in this direction, so this will be the height. This is the height of the object from that point to the ground surface. Always the reference will be ground surface. But when it comes to simple pendulum, the reference point will be always the midpoint. At this point the height will be 0. As it starts moving, the height will be there. But one thing is, you should not take the length of a string as height. That's it. Now we'll talk about this point first. Okay, now here the height will be 0. Assume the pendulum is moving now. Assume the pendulum is moving, oscillating. At this point, height will be 0. Height will be 0. If the height is 0, what about potential energy? potential energy will be 0. Okay, but what about kinetic energy? Kinetic energy will be maximum. Kinetic energy will be maximum. See, this is not the formula for kinetic energy. Whenever kinetic energy is converted into potential energy or potential energy is converted into kinetic energy, we can assume this as the formula for kinetic energy. Don't worry about that. Okay, now, so at this point, potential energy will be 0, kinetic energy will be maximum, and when we add it, we should get mgh only, that is the maximum value. Okay, that is nothing but mechanical energy will be constant only when there is no friction. If there is no friction, we are talking about vacuum. If we are talking about the vacuum as a medium, then mechanical energy will be always constant. Okay, now when this pendulum it start moving in oscillating in this direction, okay, towards left side, the height will keep on increasing, correct? The height will keep on increasing. As the height increases, okay, the kinetic energy, maximum kinetic energy what we have, that will keep on converted into potential energy. Okay, when it reaches the point B, the extreme end, the left extreme end, for a fraction of second there will be no movement. There will be no movement, but it has maximum height. If it has maximum height, what it has? It has potential energy, that is nothing but mgh. For a fraction of second it is not going to move. Then if it is not moving, what about kinetic energy? Kinetic energy will be 0. Okay, now we'll talk about this point. See, the extreme end towards the right side, at this point again the height is maximum, and for a fraction of second it is not going to move. So here at this point also u will be mgh and kinetic energy will be 0. Okay, apart from these 3 points, anywhere, okay, we have both kinetic energy and potential energy. See, at midpoint, okay, here there is only kinetic energy, no potential energy. At these 2 points, extreme ends, we have only potential energy, no kinetic energy. Apart from these 3 points, we have both. Anywhere, if you take the here or here, anywhere, we have both kinetic energy and potential energy. When we add it, we will get the constant 100% value only. If you understand this one, see, to explain this one, he has used in the textbook, he has used around 1.5 pages. If you understand this much, that is what he has told as a story. That's it. If you have understand this, I think we have covered everything related to the concept video when it comes to conservation of energy. Now we are going to solve each and every theory question. After that, we are going to solve numerical questions. All those 2 videos separately, that will be available in the description box. Thank you.